Hello friends and welcome at my channel. Today I would like to show you something about factor rule and sum rule of the limits and also of the differentiation. So they are connected. If you remember the definition of the first principle, it was f prime at xo. It was the limit h towards 0, f of xo plus h minus f of xo divided over h. So basically what we were doing is we were computing in the last few videos different examples where we also have seen some examples where the derivative wasn't given at 0. If you remember, for example, the absolute value of x, 1 divided by x, and the square root of x, these were the bad boys. Alright, so what we're gonna do now, we're gonna see how it is possible to simplify the computation if, for example, we have a constant number multiplied times a function f of x. For example, if you have something like 5x and you want to produce a derivative out of this, you just kick 5 outside of the derivative by the factor rule, which we're going to show in a moment, and then you have x prime and the derivative of x was 1. So 5 times 1 is just 5. Alright, so let us start maybe with the factor rule of the limits. And the factor rule of the limits is telling us, so let's write factor rule of limits. And the factor rule is telling you if you have a limit of x towards 3, for example, of 7x. Well, basically you can put x immediately. We define it this way. It's a kind of expanding of substitution. So we put 3, it's going to be 21 on the one hand. And on the other hand, if you have 7 in front of the limit, x towards 3 of just only x, that's going to be the same outcome. This is still 21. So that's the story. All right. Of course, once we start working with epsilon and delta for you guys from the universities, or at different special courses in mathematics, we're going to prove it differently. There are special different definition of limits, but for our purposes so far, it's absolutely fine to understand if there is a constant number which is independent on x, we can easily take it outside of the limit and we're not changing a thing. So the factor rule statement is if there is a limit x towards a of f of x, which gives us a capital A as a result, and if there is a k real number, which is a constant number that we're working with, then the limit of x towards a of k times f of x, this is just the same result if we have k in front of the limit x towards a of f of x, and that would be just k times capital A. This is the factor rule of the limits. And now we just immediately apply it to the factor rule of differentiation. Factor rule of derivative. So, what is the statement? Well, assuming f of x is a differentiable function, differentiable means we have the first principle, for example, or the x method is working properly. We have a unique existing and finite slope. Then k is a constant value. Define g of x as k times f of x. Then the derivative of g of x, so g of xo, it's going to be a limit h towards 0, g of xo plus h minus g of xo divided over h. Now, by the definition of the function g, we know it's k times f, right? So it's k times f of xo plus h minus k times f of xo divided over h. Now, using the distributive law, we can kick k outside of the derivative, outside of the numerator. We just have f of xo plus h here, minus f of xo divided over h, and now by the factor rule of the limits, we can keep this value of k, which is totally independent considering h, outside of the limit. And what we're gonna have here, limit h towards 0, f of xo plus h minus f of xo divided over h. This is a derivative of f by the first principle. So since the function was assumed as differentiable, this derivative exists, and we get this as a result. So this is the proof of the factor rule. In the next video, I'm going to show the sum rule of limits and also the sum rule of derivatives. Thanks for watching. See you next time. Bye bye.